So what we will be discussing is the last major topic that you will be practicing in the lab. Then the last topic will be on security, which is more awareness with a little bit of practice, but you will not apply it to your homework or your project. Okay, so what we have seen so far, we started looking at Java EE and how it can help us build web applications. And we've seen so far how to do entities, how to do repositories, and how to make such repositories web accessible using REST services. Now, for the repositories, so far, we have seen how to do them by keeping the object in a list, in memory. But that's not, of course, that's not realistic. That's not how people usually do it. In most realistic scenarios, people will use some kind of database to store such entities. And for databases, in the past, whenever you talk database, the relational database come to mind, but that's now no longer the case. So there are multiple types of databases you can choose from. So we looked at MongoDB as one of them, and the relational database as another example database that you can use. So in the remainder of the course, we will go back to relational database, just for you to be able to do the bridge between what you've seen in 351, the database course, and this course. So we are back to the relational database, but you will see it with a bit different, with a little bit different way, complementary to what we have seen. So let's hope this projector will come up. Okay, so unfortunately all my pens have disappeared. All right. Okay, so in a relational database, what are the main concepts? Tables, very good. Tables with the relationships, and we establish relationships using foreign keys. Okay, and also we know every table kind of has a primary key. So these are the main concepts. Now, when we develop our applications, we usually use some kind of object-oriented programming. We deal with objects, and then we have to use from our program. We want to be able to read and write from the database. Okay, so to do this, we basically have two major ways to do it, two major APIs to do it. There is an API called JDBC, Java Database Connectivity, that you have seen in 351, and hopefully this projector will work, and I'll give you a very, very quick review. And a much better way is another API, new API called JPA, Java Persistence API. And we will focus more on the Java Persistence API because of its benefits. I will explain them shortly. Okay, let me try one more time. So let's start with a quick review of JDBC. So in JDBC, how do we program? What are the steps? In a very simple way. Very good, we connect. Then? Okay, we write a query which is in which format? Which is a string, using an SQL language. So we connect to the database, we create what is called as a statement, and we submit it to the database, wait for the results to come. We receive the results, and we do whatever with the results. Okay, so this is how it looks. This is my application. I use JDBC as a standard API, as a standard way of talking to any database. So here it could be MySQL, SQL Server, Oracle. You know, these databases have different interfaces and different ways of interacting with them. So as a developer, I don't want to waste my time. Every time I need to interact with the database, learn how to do it. for a particular database. Instead, I learn one interface, one way of doing it, which is JDBC. And then this JDBC allows me to talk to any database. And the difference is, and what enables this is this driver between my program and the database. So when I make a call, the driver is the intermediary that will translate that call to the database API. So who provides these drivers? Sorry? The server, the Java, the API? Okay. So the Java itself has the API, okay? The one that provides the driver is the producer of the database. So if you use MySQL database, from where you get the driver? From MySQL. Go to a MySQL website and you download the driver. Okay. If you want to use Oracle, you use the Oracle driver. If you want to use SQL Server, you use the SQL Server driver. So similar. The idea is similar to USB, for example. It's a standard port, standard interface. And then you can plug in their printer or a scanner or a mouse, whatever it might be. And basically, the computer will interact with that device through a driver. So that's why when you plug, it asks you, install the driver. So the same idea is that, and all of this is just to keep the developers happy and they don't need to learn a lot of APIs. Yes, and a lot of ways to interact with databases. They learn one way, and the driver takes care of the rest. Okay, so that's the concept of JDBC. It's very popular, very widely used. And JDBC gives us three main classes that we deal with as developers. There is a connection class that we use to connect to the database. Statements class is used to send some statements, SQL statements. And then if it is a select statement, we receive back a result set. What is a result set?
The records that we asked for.
Yes, it's a tabular data structure. So it has columns and rows. Okay, so that's basically how it works. And the steps are like this. We always do it like this. We connect, we get a connection object. From it, we create a statement object. We use it to send queries, and the database will process our query, give us some results, and then when we get back the results, we might display to the users, we might convert it to a list of objects. We do whatever we want with the results, and we don't forget to close the connection. That's most of the programming is done like this. Now, here is a typical one, but it looks a bit different in the Enterprise Edition. So here is but there is a better way. Here is kind of, if you want to use JDBC, that's how you will do it. Okay. So in here, I'm doing a try and catch. And then in the try, I create the connection, and I create the statement. Why do I create them in the try statement? See here, try, I open the parentheses. Now, even if the connection failed, I can put it inside, not with. Have a look at this. Have a look carefully. Okay. Have a look. No, I'm creating the connection and then creating the statement. Yeah, I know, this is sequence, one after the other, that's fine. But why did I do it in parentheses after try? No, I could move them here. I could move them here and I can still catch the connection. For finally, yes. First time? Okay. By the way, this is very, very important addition in Java, in the latest version of Java. Thank you very much. This is for auto-closing. Remember, the connection and the statements are you are connecting to a remote server. And that connection will remain there, Connection is like establishing some kind of route or some kind of path between your program and the remote server, and you should explicitly close it when you are done with it. Of course, the developers, once they see they get the results, they forget to close. Okay, and it's not good for performance and for memory usage and so on. So the Java latest edition, I think from version 7 and above, they came up with this. So if you do it in try and open parentheses and then create the objects, they will auto-close. So you don't need to close them. Because they know developers, they lazy, they don't close or they forget. So this syntax auto-closes. Okay? So as you can see here, I create the connection. From the connection, I create the statement. From the statement, I execute a query. I give it the select statement in this case. I get back a result set, which is a tabular data structure. Typically, I'm not really interested in dealing with this data structure. Usually, I want to convert it to a list of objects. Usually, it's not a good idea to just return it. If you return it, the receiver will just receive a table. Instead, I prefer to go through it, read each row, pick up the data from each row, construct an object that you can see here, add the object to a list. When I'm done, I return the list. You following? And the caller does not even care whether there is a database or there is. But if you return this, they are aware of JDBC. If you change your mind to use some other technology, they are also need to change. But if you do it this way, they don't even know what you're using files or using JDBC, JPA, whatever you are using, they don't really care. Okay? But this is very painful. You have to unpack data and then push it to objects. And that's one of the limitations of JDBC. One of the serious limitations is that you have, when you get the results, you don't get them as objects. You get them as data set, and you have to unpack it yourself. Same when you have an object and you want to insert it in the database. What do?
You have to create a set one by one.
Yeah, you have to construct an insert statement string. Even worse than this. You have to do a string and keep adding those. And if you do any little mistake, of course, you will have a bug in that string. So it's not very elegant. And of course, if you are lucky and you have some beginner in your team, you give them this job to do, okay? Because it doesn't need any intellectual challenge or anything interesting. It's just packing and unpacking, okay? So nobody wants to do this. That's why people invented this GPA as a way of avoiding this. I will explain how, but this is one of the serious limitations of JDBC. Because really, there is a gap between these two worlds, the world of database and the world of object-oriented programming. There is a huge gap. Because in the world of database, we talk about tables. In the world of programming and object-oriented programming, we talk about classes and objects. This is how we bridge the gap. It's not a very nice way. We, as developers, have to bridge this gap. You following the problem here? Okay, so before I move forward, let me show you something different compared to Java SE that you have done in 351. Compare it with Java EE. Because remember, our program runs inside this container. In our case, the GlassFish. That has a bug that you hopefully have fixed in your laptops. Okay, so here it is. Which means, just since I mentioned that, because it's open source and you didn't pay much for it, that bug is still there and they know about it and they've taken their time to fix it. If it was the commercial one, in few days or hours it would have been fixed. Anyway, so in here, if you remember in your 351 course, you used to connect to the database yourself. You create a connection object and you use a connection string. Remember connection string? What does it have? Yeah, you put You put the server name, the port,
yeah.
the database name, the username, remember?
Yes.
Otherwise, how can you connect? You have to tell the system, you have to tell JDBC, where is your server, what was the port, what is the username, what is the password. Remember this? But in here, we don't have all this stuff. Just magically, because we live in a serviced apartment, in a serviced container. So when we want a database, connection to a database, we just ask for it. Say, please give me a data source. And we add this annotation, add resource. And we give it the name of the data source that we want to have access to. And then the server will give us a data source to allow us to connect. So on the server, we configure data sources. We configure them. We say we have a couple of databases that we want to interact with. We configure them once on the server, and then whoever wants them, what they need to do, if you want a data source, declare it and add this annotation. And then you get an instance at your hand, and you use that instance to connect and to run your statements. You following? Where is the details of the database? The server name, the ID, sorry, the username, the password, the port, all that information. It is configured once on the server. So let me just show it to you very quickly, although this is not very critical. But let me just show you here. So if I go here, if you remember that, you remember this administrator console that we've seen last time? So one thing you can do here, you create what is known as a connection pool. So a priori, the server will have many connections created a priori, created up front, so it doesn't waste time connecting. It's already connected. And whenever somebody wants them, they get one connection or one data source from this pool. So in here, when you create it, I'm not going to show you how, but just to give you an idea, when you create a data source, for example, here I have a Derby data source. In here, I specify all the information. Okay? And I specify this is the server name, this is database name, this is the password, the username, the port, and so on. And then I give this data source a name. And then when I want it on my program, I just declare a variable data source. On top of it, I add @resource, and I give the name of the data source that I want to get the connection from. Okay? So you can do it here through this administrator console. But for us, just to keep things simple, in your projects, or it's not a project, in your homework, there is a little file here called GlassFish Resources. Open this file. What you will see is, please copy this file to your project. Copy it to your project, and just do search and replace. In here, I'm talking about contact DB. Change contact to whatever it might be, employee or books, whatever you are dealing with. What this is doing, it creates a connection pool. In this connection pool, you specify the name of database, the server name, the password, all that stuff. And from the pool, you create what is known as a resource. So it's a two-step. You create a pool, and you create a resource. So just to bring the idea a little bit closer to your mind, so the server, as I mentioned, creates a pool of resources. And whenever somebody asks for them, you are given one of the connections or one of the data sources in the pool. Let me give you an analogy. Like there are companies specialized in security. Okay, if you have an event or you have, if you want some help, some helps to secure some place, you just call them. Okay, and then they send one for you, and then when you have finished your events, they come back to the company to be assigned to another task. So same thing. When you call them, they don't say, okay, please wait another month. We have to employ that person, get his visa, get his papers, and settle him, and then we will send it to you. That's not how it works. They already have a pool of resources of security guard just waiting. Whenever you ask, they are there. Same thing here. That's what a pool is. It's a pool of pre-created connections, and whenever you ask for one, you get one. When you finish with it, it comes back to the pool. This is one of the services the server provides to your application. Is clear? The idea clear? So, although you don't need to worry too much about it at this stage, you just copy this file, very important file. It's written in XML. So copy this file called GlassFish Resources. Sorry, let me just move this guy here. See here? It's not very clear, but it's called GlassFish Resources. Copy it, and the configuration file, copy it there, and then change. It's safer to just do copy, search and replace. Whenever I see contact DB, because I'm dealing with contact, I will change it to whatever other name I wish. Okay, and this will create the pool and will create the data source. Okay, and this name. Yes, for the whole project, yes. And this name is the one that you use. You remember we have that @resource. This is the name. The name that you put here is the name that you put on top with your annotation on top of the data source.
But here it's only like one collection, or?
In here we're dealing with one database.
Yes, so we have different collections.
If you're dealing with multiple databases, no problem. You can duplicate this. Okay, and you can create multiple databases if you wish. Okay, if each one has its own name, and then you can have multiple data sources.
Why do okay, I understand why we connect the resource in the Java server.
Okay, yes.
This one.
Yeah.
But why we create the data source? It's
Okay.
there from the resource. Why we create?
You mean why we create it? No. What I mean is to create the data source on the server, you have two ways. Either you go to the administrator console and create it using a graphical interface, or you create this, you add this XML file to your project. When you run your project, it will auto-create these resources. Does that answer your question or not really?
Second line of
Okay.
when we say private data source.
Okay, you mean this one? Let me show you. You mean?
Not the annotation. I understand the annotation.
You mean this?
Yeah.
Why we do this one?
Yeah. Why it's not just from the resource with the annotation?
Okay, so look, now on the server, I create these data sources and I put in there all the connection details. Without those details, of course, we cannot know how to connect to the database. So first of all, by doing it that way, I'm not hard coding it in here. As I told you last time, there is a distinction between developers and administrators. So administrators will create those resources for us, and us as developers, we just make use of them. They tell us the name, and we put the name here. Okay? So now, why are we doing it this way? Because that's how they have designed it. So you create a data source, you create a connection, you create connection pool. From it, you create a resource, and then you can inject it into your code. So I know, like sometimes you might be wondering why is it this way? That's the way they have designed, they have developed it. If we want to make use of this, you can always not do it this way and use the previous way that you did in 351, where you hard code the connection details in your program. But that's not a very good idea. Because first of all, especially in a production environment, imagine developers knowing the password of the production server. It's not a very good idea. Okay? Or somebody hacks into this or somehow get the source code, they can compromise your database. But now, even developers, they are not able to know how to. what are the details of the connection. In real life, we don't do this, of course. This is for us to quickly create. No, I usually by the way, administrators, that's their job, is not to share with you this information. They configure it and they tell you this is the resource you need to use. Okay, they will not reveal to you these sensitive details. No, you use it to connect to the database and interact with it. That's all. Okay, so the resource, two things. It stores the details of how to connect, which is the server name, the password, and so on. And also, the connections, there is a pool of them ready for you to make use of. So it makes the performance much better. Because connecting to a database, it takes some time. Yeah, it takes some time to establish such connection. But if you do it this way, the server creates already some connections already, and whenever you need them, they are ready to be used. Okay, so it speeds up that startup time of your application. All right, so that's basically the idea. That's the basic idea. Let me just show you. Here it is. So the basic idea, let me get customers using JDBC. So here is what you do. So you create connection from the data source, then you create the statements from the connection. Here, this is no difference. You do this in the standard edition as well. Then you use it to execute the query, then you get a result set, you look through it, and you create object from each record, and then you add it to the list and return the list. That's typically how you do it. For adding, let me show you add, how add looks like using JDBC. Not very elegant. Not very elegant. What you do is you create an insert statement, insert into, these are columns and then values, and then you concatenate. You create a string, and then you submit the string for execution. Execute update. And this will return you the customer ID, the new customer ID that was generated by the database. You set it into this object, and then you return the object. So the user knows the ID of the new customer. Because usually the ID is generated by the database. You've seen this in the database course. It's an auto-incremented column. So update, here is update, how it looks like, just for a quick review. Is there any? Yes, here is an update. Same thing, not very nice. You construct a string, then you submit it for execution. Always you do the same. Okay, tables in here it's already created. These are the tables. You can go to I will explain how these tables came about. So under services, you can go here and say new connection, and you connect to. We are using a very simple database called JavaDB. It comes with GlassFish, so you don't need to install anything. There is database already running. You just choose it. If you want to connect to it, next, and basically you give the server name, which is localhost. The port, I think 1527. This is the port on which the database is listening. Database name in this case is called ContactDB. The username is app, and the password is app. Remember? And test. Yep, same information in the file. That's, you see here the test is successful. Finish, and then you will see it, because I already have one, but you will see it here. This is the contacts. If you go under app, you will see tables. One of them is customer. Okay? Now, how these tables were created, that's another story.
So after we define it,
Okay, I click here, yes, ID and name.
after we define connection, we have to do this.
No, here, no, this is if you want to debug or see, like let's say you inserted something, you want to see that it's there. So you can connect to it and view the data, you can see the data there. Okay? This is, I'm sure you have used to do this, but in a more complicated way using Oracle. Is that what you did?
It's only like one lab we did it, right?
Yeah.
One lab, and it wasn't sufficient.
That is fine. That is fine. This one is just quick review. Whatever you've seen, you will not use. There's a much better way. This is just a quick review of the traditional way of doing things. Okay, welcome to the new way. That's it. I think you have enough of traditional way. Now the new way, what is the new API to do with relational databases? What do we call it? JPA, Java Persistence API. The old one is JDBC, Java Database Connectivity. Okay, now the new API, it tries to bridge the gap between database world and the object-oriented world. How does it try to bridge the gap? Through annotations. Okay, so let me show you an example, very concrete example. So in here, I have this customer entity or customer class, and here is the customer class. So all it has, it just has two properties or two attributes, ID and name. Okay, so I have a customer class in the database. What will I have? Table called maybe customer. Okay, so I want to map this customer class to the customer table. It's like putting some bridge in between, because in the object-oriented world, I represent a customer as a customer class. In the database world, I represent the customer as a customer table. So I have to tell the system that be aware that there is this bridge or there is this correspondence between these two things, the customer class and the customer table. So how do I do this? I come to the customer class and I add this annotation. Don't worry about this. There are many annotations. Don't worry about this one. The annotation I am referring to is the at entity. Can you see it there? At entity. What this at entity does, it just says for customer class, the corresponding table is the customer table. Okay? Now, suppose there is already the table already there, and the table has a different name. You can come here and say name equal customers, for example. You have some DBA, they said, no, I'm not going to change my tables, and I like to have S in my table names, although it's not a good idea. They insist, you're not going to fight with them. Say, lakum your naming, and liya my naming. So, and then what you do, you come to your entity and say name equal customers, okay? And basically, you don't need to change your class and follow some weird convention. Nobody will like it. You keep your name and you map the two. So in the ideal world, you have some collaborating administrator, or you are doing both jobs. Of course, ideally you want the same name. This is the idea. If it's not, you can always add some more annotations to map them. You clear? So by default, the customer table will be mapped to the customer class. Now, in the world of databases, we have this idea of primary key, okay, to uniquely identify each record in the table. In the object-oriented world, we don't have this idea of primary key. So that's why we tell JPA, oh, by the way, this is the primary key of our table. So I come to this attribute and I add this annotation at ID. Okay? And sometimes the ID is auto-generated. Many times the ID is generated. I also come and tell JPA about this information. I say, oh, by the way, the ID is generated value, and it is generated using an auto-incremented column. As you insert a new customer, the ID will be auto-generated. So that's all you need. Later on we will see. You can also have, you can remember that tables have relationships between them. It can be one to many, many to one, many to many. In the object-oriented world, you also have this concept. You have relations. So you can also map those relations. Okay? Remember, a customer can have one or many orders. So what's the relationship? Yes. It's one to many. One customer has, yes, a list of orders, yes. I can also add that annotation. Can you see here? A one to many. But I will explain this more later. Let's just focus on this one. Okay? So what is the advantage of adding these annotations? Why should... What, yeah, well, okay, I have done it. What is the benefit? What I will get out of this? Just extra annotations? Sorry? Simple code in what way?
I didn't do the connection myself. I tell them, do the connection, this is my class, do it with the database. We're not constructing it. There is background.
Okay, very good, yes. So first of all, I can generate the database from this. That's the first thing. So I don't need to go and create my tables myself. This is very, very powerful. If you invested effort in your class, in your classes, and you put the annotations, when you run your program, if the database is not there, it will be auto-created. That's advantage number one. Or the other way around. If you have a database, you can generate the classes from it. Are you following? So it's a really bridging the gap between the two worlds. If you have classes, you can generate the table out of them, and if you have the tables, you can generate the classes. So you invest in one, you invest the effort in one thing. Either you invest in a good class diagram with we generate the code and do the annotations, and then generate the database, or vice versa. Okay? Second advantage, have a look at this. Have a look at my repository. Here's the customer repository, and here is get customers. Get customers. Have a look. Here is get customers. All I do, I go, there is a new class called Entity Manager. Very, very important class to allow me to interact with my database. So let me show it to you very quickly, Entity Manager. So I create an instance of this Entity Manager. I don't create it, just ask for one. So I do private Entity Manager, and then on top of it I do persistence context. Don't worry about the names of these annotations. They are a bit out of... I don't like a lot of the names, but that's how they have named them. So if I want to talk to a database using JPA, the first thing I do, I go to my classes and add the annotations. The most important annotations we've seen, at entity on top of the class, at ID, and at generated value. Once I do this, that's all I do. Once I do it, it gives me so many benefits. One, I can generate the database from my classes. Two, I can use a new way of interacting with the database, much simpler way. So, and the door to interact is this new class called Entity Manager. So I declare it and add the annotation to it, persistence context. And what this will do, you will get, the server will give you an instance of this Entity Manager, and you use it to communicate with the database. Have a look at get customers, how it looks now. Here is get customer. I just go to Entity Manager, I say, please create a query. Here is my query. Get me the result list. And the good news is, what is the result? What is the data type? Yes, the list of customers. What did I save? Doing it this way? Yes, I now save the considerable time unpacking the data from the result sets and putting them into the objects, or giving that work to some beginner in my team. Okay? This is automatically done. Like, by the way, JDBC is still in the background, but we don't deal with it. Are you following? So using the entity manager, I submit my query, I get back objects. That's it. I don't need to do that mapping between the table format to a list of objects. If you want to do it the JDBC way I showed you, here's the JDBC way. Have a look how many lines of code extra. Let me just bring this down. Compare this. One line versus many lines, plus in here I only limited to 2 columns, which is unrealistic. Tables have hundreds of columns, can have hundreds of columns. So this is a major saving. Now, have a look at if I want to get one particular by ID, by primary key. Get customer by ID. Here it is. Very, very simple. Entity manager, and I say, please find me a customer by ID. This is the ID, and when you return it to me of type customer. Okay? And I don't need to write any query. Just to find, it will go and find it and return me the results as an object, not as a result set that I have to look through and extract what I need. Now for add, let's have a look at add. Where is add? Okay, since add is, here is add. Here is update. Super simple again. Merge. Entity manager.merge, give it a new customer, it will insert it. I don't need to update the customer, set all these columns and keep concatenating into this ugly string and then submitting it. Entity manager.merge, give it the object, it does the work. Of course, in the background, it generates on your behalf an update statement. Okay, let's look at the add. Let's have a look at the add. Where is the add? I can't see it. Here. Here's the add. All I do, entity manager.persist. This flash is not really needed because the reason why I put flash is that you can do lots of things in one go and then push it in one hit. But yes, like kind of comment. Yes. So it's very, very powerful new API that saves considerable through first, once you do these annotations, you start using the entity manager to read and write to your data source. Okay, and you can generate the tables from the classes or vice versa. Yeah. Yeah. What do you mean document? Here, this is a relational database.
Because the other database we use, if we make return,
Yeah.
before return,
Yeah.
in the object, if I print it, it will be a document.
Yeah, in here, no. In here, first of all, this is a relational database. All the data is in a tabular format, rows and columns, and basically there is no document concept or JSON or so you can now see that there are many types of databases. Some of them are document oriented like MongoDB. Some of them are relational. So of course, the relational are more traditional ones, but they are very heavily used. You cannot ignore them. So that's why I try to give you a flavor of both worlds. And we are back to the relational because you've seen a whole course on it, and it will be good to bridge the two worlds. Yes. All right. Yeah, delete. Yes, delete also is very simple. So delete. There is better way maybe, but this. You find it, get a reference, or you do find. Get reference is just gives you a reference to it, not bring it all, and then you remove it.
Like the ID in this case, that would be returned, right? And they get reference?
لا احنا بدنا اياه بتاع
Um,
Okay.
Yes, it's not a full object. There is a find and there is a get reference. Find will bring you the whole object details if you want to update or show it to the user. But for delete, you don't want to bring everything. Okay.
Which one again? Which
Yeah. In terms of inner implementation, I'm not really sure. This is the way it is implemented internally. It's not really revealed unless you dig down into the documentation. But basically, the recommended way, or there is a better way, I think. But there is a better way. There is a better way. You can do immediately delete. I honestly, I always don't like things that you read first and then remove. You can always do execute a query, and you give it a delete. Okay. In fact, I will change this one to show you that other way better than this one. But even if you do this, don't do find. Do just get reference. It's in terms of performance a much better performance. But in my opinion, it's better to just issue a delete in the first place. No two operations, get and then remove. No, for find is only by ID. If you want to find by other attribute, you write a query. Yeah.
So entity is limited, like entity manager is limited.
No, entity manager is very powerful. Here it is. For example, here I just want to find the count. So I write a query. I'll say entity manager dot create a query, give it the query, and then I say here get single result and whatever I want to do. Okay. So when you are not finding by ID, you use a query to do that. Now, for
Understand it's the normal relational one that we use.
SQL, قصدك.
The way you write it.
Yes, this SQL statement. Now, this is a bit tricky. Here it looks like SQL, but it's not SQL. It looks very similar. Have a look at this. It looks very similar. But in SQL, you would have done here c.star. Otherwise, it will not work. This one is called GPQL. You are really doing a query against the object, not against the table. And the advantage of this, by the way, this query will get compiled. If you put a wrong column name, the compiler will tell you have a wrong column name. If you use plain SQL, you will not find out the error until runtime. When you run it, it will crash, and then you will find that you are referring to a column that does not exist. So JPA is a really very, very powerful new API that added a lot of value in interacting with the database. So there is much more to this. That's what kind of 15 minutes allow me to do. But just to summarize, you first annotate your classes to map them to tables. Then you use Entity Manager to either query, insert, update, delete. In terms of annotations, you can annotate relationships. You can have one-to-many, many-to-one relationships. You can also annotate inheritance. You know how in object-oriented programming we have inheritance? Let's say employee, full-time employee, part-time employee. In database, we don't have that concept of inheritance. So you can map inheritance to tables using different strategies. That's what we will see. Yes. Like basically the slides, I already posted them, and I will explain them as we move forward. We still have other sessions. So in here's the annotation. It explains the annotation very simply. This is the basic minimal annotation at entity and ID. This is the minimal. This is very widely used, generated value, because a lot of IDs are auto-generated. These are the minimum annotations, and then you can go into, if your administrators insist in having different names, you can always add the name. Okay. You can annotate relationships. This is a one-to-many and many-to-one. You can annotate it. Say the customer has one or many orders, and an order has many. No, it's a many-to-one. So an order, here it is. An order is the many-to-one. and the customer is one to many. You do this annotation. And here you specify the foreign key, joint column. Okay, so basically the order is joined with customer using the customer ID. And because you already defined the join column here, you don't need to define it here. You just say mapped by. So the join column is specified once. So in mapped by, you specify the name of attribute in the other side. I will explain this. I will explain this further. And then you can also annotate, as I mentioned. You can annotate, lastly. We will see this. You can annotate inheritance like this. Okay? And there are various ways of doing it. All right. So those are the basic capabilities. You need to learn the annotations. You need to learn the entity manager methods that it has. You need to learn this query language, which is very similar to SQL. If you don't like it, you can use SQL. And that's the basic skills. Yes, yes. In the entity manager has two methods. One is called create query, and one is called create native query.
Native,
yes, DSQL. Native is the SQL, and the just create query is this GPQL. Okay, it's called the GPQL, which stands for Java Persistence Query Language. Java Persistence Query Language. The advantage of using GPQL is that it gets compiled. It gets validated at compile time. If you use SQL, it doesn't. You have to test it because it is just a string. It doesn't look at, the compiler ignores it. Until a runtime, you find the problems. Oh, yes, please. Sorry? Native? Okay. The difference, there are some slight differences. Like, for example, as I showed you in here, in GPQL, you just specify the alias of the object you are querying. In SQL, you have to specify either .star for all the columns, or you specify the actual columns, c.id, comma, c.name, and so on. Okay, so these are the slight differences. This is GPQL. This is exactly the same as SQL. Here you are aggregating and finding the count. But in SQL, you will do here c.customer ID or something. You don't just see. No, in count, no, you don't put star. In count, you can put one of the columns to count. Yeah, star is to get all the columns. Okay. So in here, I just wanted to introduce. So next lab, you can play with this a little bit more, and then we come back and go into more details about it. This is important to be aware of it because it can save a lot of time in a realistic project. Yeah. Yes. أول شيء يعني كل شيء يكون شغال يعني بدون database. Okay. All is in memory lists. Make sure the services are working, and then you go back to the repository and add annotations to one simple class first. Something very simple. Yes, for the entity classes you add the annotations, and for the repository you will change it to use the entity manager to read and write. Services should not change, and of course the UI should not change. Sorry? The UI, okay, very good. The UI, like in the you mean the user interface for your project? Okay, this is a very good question. In the example I provided, sorry, let me just, in the example I provided to you, sorry, let me just delete this one because I had the intention to delete it, not to confuse you. Okay, here's the UI. The UI, you put them under this. You see this folder called Web Pages? Copy the UI from Homework 3 and paste it there. When I say UI, the HTML, the CSS, the JavaScript, the client-side JavaScript. You just put them in there. One of the files should be called index.html. So when you run your application, it will open. خلاص. You need to place them in the right place. That's all. So the previous UI should work. Okay? Because the previous UI deals with services. Except in the JavaScript that talks to services, you might need to change the port. If it's the port and the URL, because I think maybe because in the Java EE there is the server dot. Yeah, like localhost : 8080 is the port slash the application name. Like in my case, it's CMS. Well, in fact, look. Yes. Yes, you're right. Yes, the URL will change. But the good news, you can even do the URLs, relative URLs. Let me show you very quickly here. Here is the relative URL. Is there any fetch here? Yeah, this is not very good. No. You don't need all of this. You can just do it this way. This will work. Yes, it will refer to the current path. Yes, you will see some errors here because NetBeans is not up to date. It does not know you are using Java 2015. So it might give you some errors, but don't worry about them. Like, it will work. All right, let me. You see here, I'm doing it here. Have a look. I'm just doing API/contacts. That's all you need. If you put relative URLs, that's even better. It starts from API. So all of the other ones, it should start from API/contacts. API/. You don't need to specify the full. But if you specify the full, it's also fine. Make sure it is 8080 the port, and make sure before API you put the name of the application. In your case, maybe it will be com. Yeah. So it will be 8080/com/API/ let's say courses or whatever it might be. All right, and keep posting to Piazza. I will answer. No, for the homework, no. Like, just keep it simple. One repository, one service. It's fine. Just to keep things simple. But if you want to change, it's fine. If you want to distribute it in multiple, it's fine. Put them in one is also fine. Yes, please.
When you call a URL and it's landing on that file,
Yeah.
if you want to change it, you don't want to like slash, for example, student. You need, for example, slash staff or slash another thing.
That's fine, because remember, at path can be applied to the class level, can be applied to the method level.
Yes.
So if you put it in the class level, so whatever you put in the class will be all in all the paths. It's like a folder and subfolders.
Yes.
So if you put it in the root, let's say.
That root, you're not related to that root. You will start all over in the.
No, unfortunately, if you want to do that, don't put in the root. Don't put in the class level.
Okay.
Put in the method level. Yes. In the method level, you say /courses. If you have a service that is not homogeneous, which means it has a little bit, the functionality is not, you are trying to make it simple, put all in one service, and which is not related, not all of them very much related, then better to do the path in the method level. ما فيش مشكلة. لا حيروح على /API/ whatever the path you provide. Yes. So at the class level is optional, but if you put it at the class level, it applies to all methods. It's like a main folder and subfolders. Okay, thank you very much.